All right, here are solutions for perfect problem 2 for Math 211. What's going on here is we have a 3-set Venn diagram where set A here represents, first names that start with a vowel. So maybe I'll even write A equals vowel up here just for my own reference. And then B represents all first names that are more than 6 letters long. So B equals maybe long. And C represents all first names that have an S in them. Good enough. Okay, and what we're asked to do is find a name that belongs in each of the 8 regions numbered below. So region 1 would be a name that does not start with a vowel, that is not long, and that does not contain an S. Let's see, so long is defined to be 6 letters or more, I think. Yep. So Brian is a fantastic name. It does not start with a vowel. It is not longer, 6 letters or longer, and it does not contain an S. So a good answer for 1 would be Brian. What about 2? Well, region 2 here is a name that starts with a vowel, but it's not long and it does not contain an S. So a short name that starts with a vowel, I don't know, Alex maybe, sure. Starts with the vowel. I don't know why the L is capitalized, but I'm not going to erase it. It's not long. It does not contain an S. What about 3? Okay, so 3 here is I'm in the intersection of vowel and long. So I want to start with a vowel and be long, but it cannot contain an S. So let's see. Alexander, sure. Starts with a vowel, long, doesn't contain an S. What about 4? Well, region 4 here, I want it to be long, but does not start with a vowel and does not contain an S. So, let's see. Christopher contains an S. Bummer. What's another long name? Jennifer. Sure. That does not start with a vowel. Does not contain an S, but it is long. All right, 5. Oh, the intersection of all 3. This is the intersection of A, B, and C. So it starts with a vowel, is long, and contains an S. I should have thought about these before. Isabella, yeah, Isabella. That's long, starts with an I, contains an S. Cool. 6, I want it to be in the intersection of A and B, so I want to start with the vowel and contain an S, but to not be long. So a short name that starts with a vowel and contains an S too is pause that because that was taking me way too long. Elise, that works, right? It's not long, not longer than 6 letters. Starts with the vowel and it contains an S. Fine. 7, okay, so we want long and contains an S, but does not start with a vowel. I'm going to pause again. I already said that one. Christopher. That's definitely long. It definitely contains an S. It definitely does not start with a vowel. Okay, we're almost done. 8, last one. I want it to contain an S. However, I don't want it to start with a vowel, and I do not want it to be long. Sam. Sure. Starts with an S, contains an S, does not start with a vowel, is not long. All right, so I think I got all of those taken care of here. Now for the part that maybe is a little bit more relevant to our class, I'm going to express all of these regions in terms of unions, intersections, complements, and differences. Lots of different ways you can express these and lots of different possible answers. I'll just put one over here. For region 1, that's the region that's not inside any of these 3 circles. So the way I think about it is A union B union C is anything that is in any of these circles. So it's everything except for 1 here. So if I throw a complement over the top of that entire thing, I'm talking about everything that is not in the union of A, B, and C. That would be region 1. About region 2? Well, region 2 is talking about the stuff that is in A. So maybe starting with A would be a good idea. But then we want to get rid of some stuff. We don't want all of A, which is this circle. We just want this kind of funny shaped region right here. So I got to get rid of this stuff. And one way I can get rid of it is by subtracting B union C. And as long as I'm here, there's a lot of symmetry going on, right? 2, 4, and 8 are all really similar. I can find them doing stuff really similar to this. And for 2, I started with A and took away the union of B and C. For 4, I could start with B and take away the union of A and C. And for 8, I could start with C and take away the union of A and B. Okay, what about region 3 here? Well, region 3 is in the intersection of A and B, but there's a problem. The intersection of A and B also includes 5 here. So what I'm going to do is I'm going to start out with the intersection of A and B, and from that I'm going to subtract. Basically, all I need to get rid of is 5, but if I subtract all of C, I'll certainly get rid of 5 and won't get rid of 3. So I'm going to say it's A intersect B minus, or removing C. Okay, and again, I can take care of symmetry, right? 3, 6, and 7 are all pretty similar. 6, it would start with the intersection of A and C, and remove region B. All right, that's starting with this right here and taking away this. And then 7, same idea, except now I'm starting with the intersection of B and C, and I'm removing A. And then lastly, region 5, this middle guy here, well, that's the stuff that is in all 3 sets. In other words, it's A intersect B intersect C. So that should work. Maybe I'm going to say somewhere, answers may vary. Obviously, they'll vary for the names. But they can also vary over here. There's different ways you can express these different regions. So this is just one possible solution. All right, I'll call this good.